Good morning, students. Now, today I am starting with some exercise problems of inverse trigonometric functions. Exercise 2.2, question number 4, that is 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. We take the left hand side and we have so many formulas as we have discussed. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Here we are having 2 tan inverse half. Half is in place of x. So 2 tan inverse half will be tan inverse 2 into half upon 1 minus half square plus tan inverse 1 by 7 remains as it is. Now this becomes, after solving, tan inverse 1 upon 3 upon 4 plus tan inverse 1 by 7. That is again tan inverse 4 by 3 plus tan inverse 1 by 7. Now we again apply the formula tan inverse x plus tan inverse y. That is tan inverse x plus y upon 1 minus xy. In place of x there is 4 by 3 and in place of y there is 1 by 7. So we use the formula and calculate tan inverse 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7. That gives you tan inverse 31 upon 21 upon 17 upon 21. Cancel out 21, you get tan inverse 31 upon 17. So that is the value of RHS. So LHS is RHS verified. Now there I am taking another type of question in which you are given the inverse trigonometric values in the form of cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. Here we can convert cos inverse in the form of tan inverse. Cos inverse 4 by 5 is equal to cos inverse base upon hypotenuse. It means its base is 4 and hypotenuse is 5. So we can calculate from right triangle whose base is 4 and hypotenuse is 5, then perpendicular will be equal to 3. So we get tan inverse. Tan inverse is perpendicular upon base. So that becomes tan inverse 3 by 4. It means cos inverse 4 by 5 is equal to tan inverse 3 by 5. We can convert another cos inverse in the term of tan inverse also. Similarly, above process we can draw a triangle and whose base is 12 and hypotenuse is 13, and thus we get, after calculation, the perpendicular is 5. So cos inverse 12 by 13 will become tan inverse 5 by 12 perpendicular upon base. Similarly, cos inverse 33 by 65 is equal to tan inverse 56 upon 36. In similar way, we can calculate taking a triangle and base is 33 and hypotenuse is 65. Then we calculate its perpendicular will be 56. Thus we see that left hand side of above problem becomes tan inverse 3 by 5. In place of cos inverse 4 by 5, it becomes tan inverse 3 by 4 plus tan inverse 5 by 12. Cos inverse 12 by 13 become tan inverse 5 by 12. And this way we can use the formula tan inverse x plus tan inverse y, that is tan inverse x plus y upon 1 minus xy. So that becomes tan inverse tan inverse 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12. After calculation we get tan inverse 56 by 33. And similar way we can say that this is cos inverse 33 by 65 using above method. Thus we see left hand side and right hand side both are equal. So problem is verified. Now one question I have taken, prove that 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. Here the question is in the form of sin inverse 3 by 5, that means sin inverse perpendicular upon hypotenuse. So drawing the triangle, and we get perpendicular is 3 and hypotenuse is 5, then after calculation we get base of triangle is 4. So sin inverse 3 by 5 is equal to tan inverse 3 by 4 as perpendicular upon base, tan inverse 3 by 4. So problem becomes left hand side of the problem is equal to 2 tan inverse 3 by 4. Now you can use the formula 2 tan inverse x also, or tan inverse 3 by 4 plus tan inverse 3 by 4, and apply the formula tan inverse x plus tan inverse y. In place of x and y there is 3 by 4. So this becomes tan inverse 3 by 4 plus 3 by 4 upon 1 minus 3 by 4 into 3 by 4. That is tan inverse 6 by 4 divided 7 by 16. After calculation we get this is tan inverse 6 by 4 multiply 16 by 7, that is equal to tan inverse 24 by 7. That is the RHS right hand side. So thus we have proved this problem also. Now question number 5 from the exercise, change in simplest form. We are given tan inverse under root 1 plus x square upon x minus 1 upon x. In such type of questions we substitute the value of x. Here 1 plus x square, in such cases we put x is equal to tan theta or tan a. So we put the value x is equal to tan a, that becomes a is equal to tan inverse x. Now putting the value under root 1 plus x square becomes under root 1 plus tan square a, that is under root sec square a, and that gives sec a is equal to 1 upon cos a also. And similar way 1 upon x become 1 upon tan a. Now putting these values we get tan inverse sec a upon tan a minus 1 upon tan a, that is equal to tan inverse 1 upon tan a common multiply 1 upon cos a minus 1, as sec a is 1 upon cos a. This is equal to tan inverse 1 minus cos a upon sin a. After calculation we get this. Now 1 minus cos a is equal to 2 sin square a by 2. This is using trigonometric formula. Tan inverse 2 sin square a by 2 upon, and sin a is also changed in the form of half angles, that is 2 sin a by 2 cos a by 2. So it becomes tan inverse sin a by 2 upon cos a by 2. After calculating, cancel out 2 and sin a by 2 also. We get tan inverse tan a by 2, tan inverse and tan both remove it. It is obtained a by 2. And now what is a? A is tan inverse x upon 2. This is the simplest form of this expression. Now there is another problem, question number 11. Tan inverse bracket 2 cos bracket 2 sin inverse 1 by 2. In such type of questions, we go through the inner side of the bracket, that is 2 sin inverse 1 by 2. Sin inverse 1 by 2 is there. Sin inverse 1 by 2 has 1 by 2. 1 by 2 is the value of sin pi by 6. So we put the value tan inverse 2 cos 2 sin inverse sin pi by 6. Now sin inverse and sin both removed. We get tan inverse 2 cos 2 pi into pi by 6. After solving, we get tan inverse 2 cos pi by 3. Now cos pi by 3 is 1 by 2. So this becomes tan inverse 2 into 1 by 2. After calculation, we get tan inverse 1. And now the value of 1 is tan pi by 4. So that is tan inverse tan pi by 4. And removing tan inverse and tan, we get pi by 4. This is the answer of this. Now you have some practice questions of our type. Question 2, 6, 7, 8, 9 and 12 and 13. Solve these. And now some trigonometric substitutions. Remember these. Suppose function is in the form of a square plus x square. In such cases, we put x is equal to a tan theta or a is equal to tan inverse x upon a. Another type, a square minus x square is the function. In such cases, we put x is equal to a sin a or a is equal to sin inverse x upon a. Similarly, if we have a function x square minus a square type, in this case we put x is equal to a sec a or a is equal to sec inverse x upon a. These are the few substitutions. Now some trigonometric formulae. 1 minus cos a will be written as 2 sin square a by 2. A is capital here. 2 sin square a capital A by 2. 1 plus cos a is equal to 2 cos square a by 2. 1 plus sin a will be written as cos a by 2 plus sin a by 2 whole square. After opening the square, you will get the same result. 1 minus sin a is equal to cos a by 2 minus sin a by 2 whole square. After calculation, we get the result. We can use this in the different problems. 1 plus tan a and 1 minus upon 1 minus tan a is written as tan pi by 4 plus x. 1 minus tan a upon 1 plus tan a is written as tan pi by 4 minus x, etc. And rest substitutions may be used according to formula formation of trigonometric function. That's all. Thank you. Have a good day.